These are the videos for 9.2 written textbook homework problems. This is problem number 8. A, B, C, and D are all very similar problems. They're going to involve the T calculator from StatCrunch. Calculators. Let me do that again. Calculators, T, and then you have that calculator there. See if I can get those values in there. So looking at the StatCrunch here, find the T value such that the area in the right tail is 0.02, degrees of freedom 19. So all you do is this 0.02 and then greater than, compute, so you get your T 0.02 is going to be equal to what we calculated there, 2.205. 2.205, that's it. Find the area in the right tail is 0.10, 32 degrees freedom, put 32 here, 0.10 here, compute, and you get 1.309 is the next one. So T 0.10 with 32 degrees of freedom is 1.309. You're going to do the same stuff. Find the t-value, just the area in the left of the t-value is 0.05 with 6 degrees of freedom. And so in this case here, again, there's a table that you can use, but we're using technology. Degrees of freedom equals 6, 0.05. You're going to use less than, and so you should end up with negative 1.493. So your t value here is negative 1.943, and the t that we're looking for technically to the area to the left. Really what we're doing is t.95 because it's supposed to deal with area to the left. Find the critical value that corresponds to 95% confidence, assume 16 degrees of freedom. Again, in this case here, what we're looking for is t.025 because your alpha is 5% and you're going to do it divided by 2 because it's asking for a critical value in this case. So in this case, you have alpha equals 0.05, and then the critical value is t alpha over 2, so that's why we're calculating that. And if you use your calculator, you should get 2.120. That's problem number 8. So just that exercise, because we need critical values to calculate the test statistic, to calculate the confidence intervals. Next question, determine the point estimate and the margin of error. So in this case, if someone tells you the margin of error is between 15 and 35, the point estimate here, this is the point estimate, and then your margin of error is going to be that distance here and here. So what's the right in the middle of 15 and 35? That's 20. So that would be 25. So your point estimate is 25, and your margin of error would be 10 in this case here, because the distance from here to here is 10, or the distance from here to here is 10. So remember, it's x bar plus error, x bar minus error, and so each of those cases, 25 plus 10 is 35, 25 minus 10 is 15. That's problem 16. Problem 18. This one's a little bit more time intensive. Problem number 18, we're going to construct a confidence interval. So let me go ahead and put the equation up here again. It's x bar plus and minus the t alpha over 2 times S divided by square root of N. So this is the formula we're working with. So let's do A first. Your N is equal to, in this here, your sample size is 20, which means your degrees of freedom are 19. Alpha equals 0.02 at 98% confidence interval. Alpha over 2 is 0.01. So that's the area in the two tails. We need a T calculator to calculate so we can get a critical value. T alpha 0.01, 19 degrees of freedom. So we're going to put 19 here because that's N minus 1, 0.01. So we're going to use, let me switch that size, switch this again, 0.01, compute, 2.539. We'll use 2.539, 2.539. And so here we have all the values we need. Standard deviation, so we have X bar is 50, S is equal to 8. So the lower bound for A, the lower bound is going to be 50 plus, nope, lower bound is minus 50 minus 2.539 times 8 all over square root of 50. Square root of N, 50, no, not 50. What is my N? N is, where are we? Similar size N is drawn from a population. As long as the sample needs to be 50. Oh, N is 20. So we would put square root of 20 there. And so the lower bound for this one here, 18A, you should be approximately 45.5. And if you do the upper bound, it's 50 plus 2.539 times 8 over square root of 20. Your upper bound should be 54.5. And so those are our values there. That's our confidence interval. We're going to do the same thing for B. Everything's going to be the same. The only thing is we've decreased the sample size to 15. And so we're curious, how does that affect the size, how does this decreasing the sample size affect the margin of error? So I'm not going to redo all those calculations, but everything will be, well, technically everything's going to be the same. We've just decreased the sample size. So in this case, N is 15. Your degrees of freedom would be 14. That does change your alpha 0.01. Your T alpha 0.01 is going to have a different value because you've changed the sample size. And so you have degrees of freedom of 14 this time. Clear that out. Put 0.01 there. Compute. Now we're going to use 2.624. 2.624. Notice it's a different T value here because we've changed the sample size. And then what you're going to end up with, if you do all the calculations, 50 minus 2.64 times 8 times over the square root of 15, you're going to end up, I'll just write it out here, you end up with lower bound minus 2.624, 8 all over the square root of 15. So I'm using a different sample size here, 15 to 20, and then you get an upper bound 50 plus 2.624 times 8 over square root of 15. And if you get those values, you get a new confidence interval. On this one here, you get 44.6. Upper bound is 55.4. So what it looks like, what happens here when we're comparing this, decreasing, this is an important discovery here, just decreasing sample size increases margin of error. That's what's going to happen. So that's what we got for A and B. So let's go ahead and look at problem C now. So in problem C, what happens is we're going to construct the same, using the same information. This time we're going to use a 95% confidence interval. So that changes, what that changes for us, what that's going to change for us, let's try a different color there. What that's going to change for us is our alpha now is 0.05, and so our alpha over 2 is 0.025. We still have n equals 20. Degrees of freedom would equal 19. We now need our t alpha over 2, so 0.025. That's going to change because we have 19 degrees of freedom, and we've changed our alpha level. What else do we need here? We know x bar and s already. And so with that value there, remind you again how to do that. I'm going to put in 19 here. Close that out there, 0.025. And so you end up with 2.093 right here. 2.093 is your value. You get the lower bound, upper bound. Lower bound is going to be 50 minus 2.093 parentheses 8 over square root of 20. Upper bound is going to be 50 plus 2.093 8 over square root of 20. And so when you do those values, we should end up with 46.3 is the lower bound. Upper bound is going to be 53.7. And so it looks like decreasing the level of confidence decreases the margin of error. Decreasing. So how does decreasing the level of confidence affect the margin of error? It decreases margin of error. You can see that because these values get closer together compared to being 98% confidence, which had a larger margin of error. And so that's what we have. And then could we have computed the confidence intervals in parts A through C if the population had not been normally distributed? And the answer to that question for D is no, because the sample sizes are too small. And so we couldn't do it. It's problem 18. Let's go ahead and take a look at problem number 24 now. According to the Nielsen net ratings, the mean amount of time spent on MySpace per user per month in July 2014 was 171 minutes. A 95% confidence interval for the mean amount of time spent had a lower bound of 154 and an upper bound of 190.6. What does this mean? This means we are 95% confident. What are we confident of? We're 95% confident that the mean amount of time spent on MySpace. The mean amount of time spent on MySpace per user is between 151.4 and 190.6 minutes. There we go. That's what that means. Make sure you're using that language correctly. We are 95% confident. We are 90%. We're 99% confident. All depends on that. Let's go ahead and finish this homework with problem number 44. Researcher wanted to determine the mean number of hours the typical person watches TV. Results from the Sullivan statistics indicate that the standard deviation is 7.5. And so this one here, to do this one here, we need to To do this one here, we need to calculate sample size. So we need the formula that we had before. And so in this case, to calculate sample size, n is going to be equal to n is equal to, what was that formula again? N is equal to, let's pull it up. There it is. C alpha over 2 times S over E squared. And so that's what we would have there. You need Z alpha over 2 times S over E squared. There's our formula that we're using for problem number 44. And so then all we need to do is substitute values. All you need to do is substitute values into there. So for part A, n is going to be equal to, and this is a 95% confidence, so we're going to use 1.96 times the standard deviation 7.5 divided by within 2 hours over 2 squared. So if you put that value in, 1.96 here, let's clear that. 1.96 times 7, let's do that again. 1.96 times, oh my goodness, 1.96 times 7.5 divided by 2, and then we're going to square that. You get 54. And so with that 54, we would 54.02, 54. Oh my goodness, what's going on here? So it's 50. So you get 54.02, or you need 55 people because you have to round up. Part B, how many people are needed to estimate within 1? So everything stays the same. 1.96 times 7.5 all over 1 squared. And so in this case, you're going to need 217 people. You're going to round up your value. So we got that there. And so it looks like what effect does doubling the required accuracy have on the sample size? On part C, it looks like doubling the accuracy. You want to go from 1 to 2 or from 2 to 1. Doubling the accuracy looks like quadruples, means multiply by 4. Quadruples sample size. You see it goes like from 55 to 200, so quadruples it. And then lastly, on D, if we're going to answer D, how many people are needed to estimate the number of to watch TV at 90% confidence? So in this case, your N is going to be N. And then we got to change the critical value for 90% confidence interval. So if you went to, we go back to our lecture notes, and for a 90%, I gave you a table somewhere. 90% is 1.645. 1.645 is the Z value. So in this case, you end up putting 1.645 times 7.5 all over, margin of error is 2, all of that squared. And so on D, you should end up with approximately 39 people. And so how does decreasing the level of confidence in the estimate affect sample size? Why is that reasonable? And so what happens on part D is, what you figure out is decreasing sample size, decreasing level of confidence Decreasing level of confidence decreases sample size. See, we had 39 people compared to 55. Decreases sample size, and that's reasonable again because for a fixed margin error, a smaller sample size will result in lower level of confidence. So you can see kind of that connection there. That's it.